Question 4. This question is about S-block metals, so that's metals in group 1 or group 2. Give the full electronic configuration for the calcium ion Ca2+. Well, calcium has got an atomic number or a proton number of 20. So it's got 20 protons and 20 electrons. If it's 2+, it's lost 2 electrons, so it's got 18 electrons. It's lost its 4s electrons. So it's 1s2, 2s2, 2p6, 3s2, 3p6. 2 add 2 is 4, add 6 is 10, add 2 is 12, add 6 is 18. So it's had 20 electrons when it was an atom, lost 2 electrons, and now got 18 electrons. It's lost its 4s electrons, so you can just leave that off if you want to. Explain why the second ionization energy of calcium is lower than the second ionization energy of potassium. Well, calcium is a much larger atom, so if it's larger, because it's further down the periodic table, then its outer electrons are further from the nucleus. Remember, it's the nucleus that provides nuclear attraction for the electrons, so the further away there's less nuclear attraction. Also, there's more shielding in calcium because it's got more electron shells. It's further down the periodic table. Identify the S-block metal as the highest first ionization energy. So it's something towards the top, something that's small, because if it's small, the electrons are closer to the nucleus, and the attractions of the protons in the nucleus. So right at the top of group 1 and group 2 are lithium and beryllium. So the answer is actually beryllium. Beryllium because it's to the right, it's right of lithium along the second period, and therefore it's got more protons. So as you go across a period from left to right, the general trend is that the atoms get smaller and the ionization energies go up, because the smaller atoms higher first ionization energies, because more protons mean more nuclear attraction as you go left to right across the period. Give the formula of the hydroxide in group 2 from magnesium to barium that is least soluble. So magnesium hydroxide is the least soluble, and it's MgOH2. So the formula MgOH2, magnesium is in group 2, OH is a 1- ion, so 2+, magnesium forms a 2+ ion because it's got 2 electrons in its outer shell that it wants to get rid of. To become stable, OH-, 2+, minus, I need 2 OH- minuses to balance up the charges. A student added 6 centimetres cubed of 0.25 mole decimeter cubed of barium chloride to 8 centimeter cubed of 0.5 mole decimeter cubed sodium sulfate. Show by calculation. Well, even before I work out what it's asking me, I know that I'm going to do concentration. 0.25 is moles divided by volume in decimeter cubed. So I'm going to divide the 6 by 1000 to get 0.006. Concentration 0.25 equals moles divided by 0.006. And then I multiply the two together and it comes out as 1.5 times 10 to the minus 3. Number of moles of sodium sulfate, again I take the 8 centimeter cubed and I divide it by 1000 to get 0.008 centimeter cubed. Concentration 0.15 is moles divided by 0.008. Multiply the 0.008 or 8 divided by 1000 multiplied by the 1.5 gives you the number of moles of sodium sulfate. Which one's in excess? Well, which one's the larger value is barium chloride. So barium chloride is in excess. Just to go back to this one, the ionic equation of barium and sulfate. Barium is a 2+ ion because it's in group 2, so it'll form lose 2 electrons, become 2+. The sulfate ion you need to learn is SO4 2-. When the two come together, the 2+ and the 2- cancel each other out, and so it's BaSO4. Total volume of the other reagent. So what that's asking is how much sodium sulfate would I have to add for the barium chloride not to be in excess. That's broadly what it's asking. So how much more of this would I have to add to make 1.5 times 10 to the minus 3? So subtract these two, and so I work out that I need 0.003 moles of sodium sulfate, so that these are in equal amounts. Concentration is moles divided by volume. The concentration of the sodium sulfate is 0.15. The number of moles that I need to add is 0.003 divided by the volume. So the volume is 0.003 0.03 divided by 0.15, which is 0.002 decimeter cubed. To get decimeter cubed into a lower unit value like centimeter cubed, I can multiply by 1000. So 0.002 multiplied by 1000 is 2 centimeter cubed that needs adding. Now if you read the question carefully, it says calculate the total volume of the other reagent which should be used. So I've added 8 to start off with, 8 centimeter cubed sodium sulfate. I need another 2 centimeter cubed, so you've got to add 10 in total. A sample of strontium has a relative atomic mass of 87.7 consists of 3 isotopes, 86, 87 and 88 Sr. In this sample, the ratio abundances of Sr 86 to 87 is 1 to 1. In other words, they're in equal amounts. State why the isotopes of strontium have identical chemical properties. That's because they've all got the same number of electrons in their outer shell. Same number of electrons. Calculate the percentage abundance, that means how much of it there is, of the 88 strontium isotope in the sample. So I'll do spoilers on this and then you can see. So what I need to do first of all is, if the percentage of 86 strontium, let's say it's X, then the percentage of 87 strontium is also X because they're in equal amounts, so in a 1-to-1 ratio. So the amount of 87 is, everything's got to add up to 100%. So 100% take away the amount of SR86, take away the percentage of SR87. So it's 100 take away X, 100 take away 2X. Now we imagine that we add 100 particles, yeah, and out of the 100 particles, then X number of particles would have a mass of 86. X number of particles would have a mass of 87, and 100 take away 2x would be the number of particles that have a mass of 88. To work out the mass of the 86 particles, I multiply 86, that's the mass of one particle, by however many there are. 87 is the mass of the next strontium particle, multiplied by the mass by the number that they are, x, and 88 multiplied by the number that they are, and I divide by the total number of particles, which I've decided is 100. And that equals the average then, so I'm working out the average, that equals 87.7. Multiply both sides by 100, and then 173 take away 176 is minus 3x. Take this across the other side, so that becomes 8770 take away 8800, which is minus 30. Make both sides positive. 3x is 30, x is 30 divided by 3, that's 10%. So the abundance of the SR isotope, that's x is the amount of 86 SR and 87 SR, so the amount of 88 SR is 100, take away the amounts of the other two isotopes, 80%. A time of flight mass spectrometer was obtained spectrum was obtained for a sample of barium that contains the 3 isotopes. Which one would take the longest time of flight? So the one that takes the longest time down the tube is the heaviest. So whichever one has the highest mass number, and that's 138 Ba+. It's a plus charged ion. So the atom's made into a plus charged ion so that it can be accelerated along the tube. Question 4.8 is about a barium ion, a barium 1+ ion with a mass of 137. And what's it tell you? Kinetic energy equals half mv², where mass is the mass of one particle in kilograms, v equals the speed. You've got Avogadro's constant, so you're obviously going to use that to work out the mass of one particle. So what have we got? We've got kinetic energy. Yeah, we're given the kinetic energy. 3.65 times 10 to the minus 16 equals half m. M is the mass of a particle. Well, 137 of a barium particle is the mass of 1 mole. If I divide the 137 by Avogadro's constant, I'll find out the mass of one particle. That'll be in grams. I'll have to get into kilograms. So grams into kilograms, I'm going to have to divide by 1000 because that m there is the mass of one particle in kilograms, and then that'll give me V squared. I can square root it and find out V, and from that I can work out the length of the detector. So let's have a look then. Kinetic energy equals half mv squared. That's my kinetic energy I've been given, equals half mv squared. Just to simplify, I'm going to multiply everything by 2, so 7.3 times 10 to the minus 16 equals mv squared. The mass of 1 mole of 137 barium is 137 grams. It needs to be, this m value is in kilograms, so I'm going to divide by 1,000. Remember, a small unit up into a large unit, you divide by 1,000. So the mass of a mole is 0.137. I know the number of particles in a mole is Avogadro's number, so if I take this mass of a mole and divide by Avogadro's number, I'll work out the mass in kilograms of one particle, which is 2.275 times 10 to the minus 25. So I can put that in as an m value now. So I've got my kinetic energy, or twice my kinetic energy. 2 lots of kinetic energy equals the mass multiplied by v squared. So v squared equals 7.3 times 10 to the minus 16 divided by the 2.275 times 10 to the power 25. V squared is 3.2088 times 10 to the power of 9. I square root it, and V is 5.6646 times 10 to the power of 4. Now velocity is distance divided by time. You'll know that speed is distance divided by time because you go, say for example, the speed of a car might be 30 miles per hour. So distance, miles, time, hour, per means divide by. So speed is distance divided by time. I've got my V, I've got my speed, my velocity or speed, 5.6646 times 10 to the power of 4. I've got my time, it gives me my time in the question, which is 2.71 times 10 to the minus 5. There, the iron takes 2.71 times 10 to the minus 5 to reach the detector. So I multiply these two numbers together and my distance is 1.53 and it's in meters.